The Fermi paradox is really a cornerstone of contemporary scientific inquiry, famously put forward by the Italian-American Nobel Prize-winning physicist Enrico Fermi sometime in 1950 during a lunch break conversation with his friends and colleagues. It asks, where are all the aliens? Despite the seemingly overwhelming likelihood that they must exist, Fermi wanted to know why we hadn't heard from them. More than 70 years later, and the situation is unchanged. The paradox is still in play as we still haven't discovered alien life. So what's going on? Are we just a seriously slow species? And despite all of our apparent technological advancement, are we just still so hugely behind the rest of the universe that we can't even reach or recognize new life in general? Well, actually, that is one possibility. But another is that, in recent times especially, we have gotten closer and closer to uncovering the truth. It's just that we're looking in ever so slightly the wrong places. Theories on information panspermia suggest that everything we need could be all around us already. It's simply a matter of identifying the data that's required and decoding it. General panspermia is the theory that life could pervade throughout the universe. Of course, we know it's on Earth, but panspermia says that maybe our planet isn't so special after all. Instead, life is carried via a number of means through the cosmos, in dust and gas, for example, and so it actually collects and distributes anywhere and everywhere. In fact, according to advocates, it's potentially how life got to Earth in the first place. Rather than abiogenesis during the earliest stages of evolution, it was panspermia that seeded this world to flourish into what it's become. Or that's the idea anyway. There are extensions to and specifications of the theory, though, including directed panspermia, which is the notion that none of this universal spreading is at random. For those backing the directed kind, life not only exists throughout the universe, it's also deliberately guided to where certain higher groups want it to go. Interestingly, the British biologist Francis Crick, most famous for his role in unpicking the double helix structure of DNA, was said to be an early proponent for this way of thinking. In the early 1970s, almost 20 years after his DNA breakthroughs, Crick suggested that advanced intelligent life forms may have sent the first bits of life, namely proteins, to Earth via a futuristic means of high-speed space travel. It should be said, though, that in later years Crick did row back on some of those ideas. Nevertheless, there are other versions of panspermia too, and when it comes to alien DNA, perhaps information panspermia is where we should really be looking. Invention of the term is attributed to the Armenian physicist Vahe Gurzadyan, and while it doesn't have quite as full a history as most other panspermia models, many believe that this one really could provide the answers we've been searching for. In short, that it really could solve the Fermi paradox. Information panspermia envisages that life might easily be passed around through space if it's compressed down into reconstructible data. By way of explaining this, Gurzadyan expands on a term usually more closely associated with computer science, Kolmogorov complexity, otherwise known as algorithmic complexity. It's a measure used to determine the simplest and shortest way that any one thing or object can be translated down into a code that could then be used to reproduce that thing or object at some other time or place. In general, it's an essential idea in the terms of the speed, efficiency, and accuracy of digital programming. With theories on information panspermia, though, the same concept is applied to something far more consequential from our point of view: life itself. To some degree, human DNA, the human genome, is also just a long line of bits of information. The same goes for any animal, plant, or any life form at all. Strip it all back to the very bare essentials and the genetic code is, well, a code, and it can be reproduced. What's especially interesting is that with human DNA in particular, contemporary research suggests that it isn't even that complicated to begin with. There are changing perspectives at play here, but in some sense, all that we really are is a trackable series of repeating patterns. It may have taken millions of years to flesh us out with bodies and brains, but that can still be boiled down to just information presented in a certain way. So could that information then be sent elsewhere? That's what information panspermia would be. DNA translated into radio waves sent across the cosmos at the speed of light, so that life may naturally appear essentially anywhere that will allow for it. It's a potentially history-breaking and world-shattering thought, both in terms of our own life story and in the search for alien life as well. On the one hand, it could be speculated that life on Earth is only here as the result of information panspermia at some point in our planet's distant past. Much as Francis Crick had once suggested that physical proteins may have been beamed here from some distant galaxies, is it actually more possible that just the information for those proteins was sent as though ahead of time? On the other hand, and in taking ourselves out of the picture for the moment, if information panspermia is viable, then might advanced enough civilizations already be doing it? It would certainly be one way to travel at the speed of light. And we of course know that the universe is full of variously unidentified light signals, many of which do reach Earth. Could it be then that we're already seeing alien life all around us? It's just that we've so far been unable to identify it? It's certainly one implication of the information panspermia theory, and as a result, one potential answer to the Fermi paradox, suggesting that aliens do exist and they are here. It's just that we need to catch up enough to view and eventually host them. Quite how the receiver of this kind of panspermia would do that, would convert and rebuild it into life at their end of the communication, is difficult to imagine. But then that would make sense if it's simply the case that humankind is simply not advanced enough to do so at the moment. That might bruise the ego of our species, but in a universe of infinite possibilities, that doesn't really matter. So what do you think? Modern ideas on panspermia have been discussed for more than a century. The first mention of information panspermia came in 2005 in a paper written by Vahi Gurzadyan. Our understanding of the human genome has rapidly improved in just the last few years. But does that mean that we could one day send ourselves to other worlds, in the hope of our species being rebuilt and recovered there? And on the other side, does it suggest that a more advanced alien force might already be doing the same thing, waiting patiently for the penny and their data to drop on Earth? Importantly, panspermia of any kind is not the leading theory for how life emerged on Earth itself. Science is reasonably confident in models on abiogenesis, most notably involving the organic emergence of life in and around deep-sea thermal vents billions of years ago. The idea then that we could be the result of information panspermia is highly speculative and controversial. However, the notion that it could be possible in general does seemingly hold some merit. The algorithmic complexity of life as we know it could, it seems, enable it all to be reduced down enough to truly travel the universe. That's a pretty exciting prospect when you think about it, and it's why aliens may well have already sent their DNA to Earth.